Good morning, everyone. We will start our program shortly. Please be with us.
Dr. Harjeet,
Yes, sir.
I think it's almost 11. We
Okay,
can
sir.
begin with the program.
Yes, sir.
Hmm.
Namaskar. Good morning. Welcome to 3 days online training program on space technology in disaster management, jointly organized by National Institute of Disaster Management, Ministry of Home Affairs, and National Remote Sensing Center, India Space Research Organization, Department of Space, Government of India. Natural disasters, whether of meteorological origin such as cyclones, floods, tornadoes, and droughts, or of having geological nature such as earthquakes, volcanoes, are well known for their devastating impact on human life, economy, and environment. With tropical climate and unstable landform coupled with high population density, poverty, illiteracy, and lack of infrastructure development, developing countries are more vulnerable to suffer from the damaging potential of such disasters. Though it is almost impossible to completely neutralize the damage due to these disasters, it is, however, possible to minimize the potential risk by developing disaster early warning strategies, prepare developmental plan to provide resilience to such disaster, mobilize resources including communication and telemedicinal services, and to help in rehabilitation and post-disaster reconstruction. Space technology is playing an important role for minimizing the adverse effect of natural disaster. Satellite imagery giving real-time information over a large area and space-based technologies like telecommunication, global navigation, satellite system, geographic information system, and web technology can be used for prevention, preparedness, relief, reconstruction, warning, and monitoring the various stages of disaster management. To enlighten us in more detail in the topic of today's training program, Space Technology in Disaster Management, in the inaugural session, we will be graced by Lieutenant Colonel Dinesh Chandra Vasisthar, Joint Director, National Institute of Disaster Management, and Sri Shantanu Chaudhary, Director, NRSC ISRO. Yes, sir.
Go ahead. Go ahead. Please go ahead.
Okay, okay, sir. Uh, who, despite their busy schedule, accept our invitation to join us in this webinar and motivate all of us with their word of wisdom. In the technical session, we will be joined by Dr. Manzul Hazarika and Director Asian and Pacific Training Center for Information and Communication Technology for Development, Professor Seswan Weston, Department of Earth System Analysis, Geoinformation Science and Earth Observation, University of Twente, Netherlands, and Dr. K.H.V. Durga Rao, Group Head, DM, SGRSA, NRSC, who will share their vast knowledge and experience. To start with our program, we have with us Professor Surya Prakash, Head GMR Division, NIDM, for his opening remarks. Over to you, sir.
Thank you, Dr. Harjeet. I thank you for giving the introduction about the program. In brief, let me just share with the participants that we have started this series about 6 months before now. On the 9th and 10th of April, we started with our webinars and online trainings in the COVID-19 situation. And during this period, we have now conducted more than hundreds of trainings and webinars on different aspects of disaster management, including the Prime Minister's 10-point agenda on disaster risk reduction. We had a lot of good partners, including the international organizations like World Health Organizations, and also the national level IITs, NRSC, and GSI, Ministry of Defense, SASE, and Central Water Commission, all nodal agencies responsible for disaster management at the national level as per our disaster management plan. Now, this is one of those activities which we had started to actually initiate the implications of technologies for disaster risk reduction and resilience. Yesterday, we had a webinar on applications of geoinformatics for disaster management, wherein we had focused on geospatial technologies, including GIS, remote sensing, and GPS technologies. We had given practical demonstrations on that. Now, next 3 days, we will have these applications from different organizations and experts, not only from within the country, but also across the country, the best globally available experts. So we have tried our best to give exposure to the best available experts and technologies for disaster risk reduction and resilience. And this has also been emphasized for our Prime Minister's agenda points 4 and 5, where it was well mentioned that in point 4, that invest in risk mapping globally to improve global understanding of nature of disaster risks, right? So this is possible primarily when we talk about regional hazards, like you talked about geological hazards and meteorological hazards, which are not confined by any boundaries. So they are more in natural perspectives, have to be studied through spatial technologies. And point 5, in fact, of the Prime Minister agenda had emphasized on that. I welcome Kiswen Weston from ITC Netherlands, who has joined just with us. Welcome to you, sir, for joining with us in this inaugural program, which is part of our series of online trainings and webinars on disaster risk reduction and resilience. And our Prime Minister's agenda point 5 actually emphasized on leveraging technology to enhance the efficiency of disaster risk management efforts. So technology in terms of spatial technologies are very much well known to cover larger geographical areas for widespread disasters of natural origins. Okay. So we will be talking about this, that how these spatial technologies are likely to benefit us, and what are the limitations also should be known to us. So I hope the developments in the techniques, technologies and tools related to spatial technologies will be well elaborated and illustrated by our speakers during the next 3 days. And we have chosen the best possible partner in the country for this purpose, none other than the National Remote Sensing Center. And we are grateful that they are led by none other than their own director, Shantanu Chaudhary ji, who has just joined with us in the inaugural program. At NIDM, we are motivated and encouraged by our Executive Director NIDM, Major General Manoj Kumar Bindal, who had actually encouraged these initiatives. Samo, due to an important meeting at National Disaster Management Authority he is not able to join us in this inaugural program, but he is likely to join us in the valedictory program. So in his place, today we are being joined by our joint director, who will be replacing executive director NIDM at this moment in the inaugural program. And since he also is busy with some other program, so Dr. Ajit, let me take this opportunity to invite our Joint Director, Lieutenant Colonel DC Basis, to kindly give an address in the inaugural program.
Thank you, sir. Thank you, Dr. Surya Prakash, sir, for inviting me for this prestigious program to start this 3-day online course training program on space technology and disaster management as we are starting. With this, I would also welcome Shri Shantanu Chaudhary, Director NRSC ISRO, who has taken his time to join us from his busy schedule and to give his keynote address in this program. I would request the delegates from the. I would also welcome the delegates from the foreign countries, especially from ITC Netherlands, who have joined us recently, and other delegates. I welcome on behalf of NIDM for this 3-day online iterations on space technology and disaster management. As we know that space technology can play an important role, as Dr. Surya Prakash has just brought out, that it can play an important role in reduction of disasters. And the aim of NIDM also matches with this aim to reduce the disasters by various aspects of capacity building. So NIDM welcome you all on this program, this course, 3-day online training program. Since we know that the use of such technology can be particularly useful in risk assessment, mitigation, preparedness phases of the disaster management. Space technology or the spatial technology, as Professor Surya Prakash has just brought out, are vital to early warning and management of the effect of the disasters. In order for the developing countries like India to be able to incorporate the routine use of space technology based solution, there is a need to increase the awareness, build national capacity, and also develop solutions that are customized and appropriate to the needs of the developing world. So with this, I once again welcome, and we would look forward for a good discussion at the end of this program, and to bring out various lessons learned for utilization of this space technology in management of the disasters. And I thank Dr. Surya Prakash, and I would hand over to Dr. Surya Prakash for further proceedings for this particular online training program. Thank you, Dr. Surya Prakash, and I welcome again to all the delegates for this program. Thank you very much, and Jai Hind.
Jai Hind. Thank you, Vasishji, for joining with us despite your busy schedule at my short request. So, Dr. Ajit, now you can carry on with the further proceedings.
Thank you very much, sir. Now, I am humbled to request Sri Shantanu Chaudhary, Director, National Remote Sensing Center, ISRO, Department of Space, Government of India, to take on the stage and grace the occasion with his special address. Over to you, sir.
Colonel DC Bashist, Director NIDM, Prakash NIDM, Professor Van Westen, Dr. Manjul Hajarika, colleagues from NRSC, faculty from NIDM, participants of the training program, very good morning to you all. As you are aware that the Indian subcontinent is prone to disasters such as floods, cyclones, tsunamis, landslides, earthquakes, forest fire, drought, etc. Providing timely information on these disasters is very crucial for disaster risk reduction in the country. Space-based systems explicitly validated their competence in providing dynamic information and services on all disaster scenarios in near real time. Our observation satellites provide comprehensive, synoptic, and multi-temporal coverage of large areas in real time and at frequent intervals, and thus have become indispensable and unique monitoring mechanism. In order to understand better the risk due to such disasters, it is necessary to integrate satellite and field-based observations and to work towards risk reduction principles. Satellite communication and navigation systems play a very vital role in disaster management with improved technological options. The disaster management support, the ISRO addresses various aspects of natural disasters in the country proactively using space-based inputs. ISRO disseminates directly the relevant information to NDMA, state DMS organizations, and through various geoportals like Bhuban, National Database Management, NDM, and MOSDAC to aid in decision making during all phases of disasters. The advent of space and its allied technologies, the disaster risk has been reduced considerably in terms of human and property loss during a couple of decades. Constellation of polar and geosynchronous satellites have contributed to the success saga Indian disaster risk reduction scenario. These satellites help in providing inputs on all natural disasters in near real time at frequent interval for situational assessment, relief, and rescue operations. Very high resolution optical satellite data can provide information on infrastructural and agricultural damage due to floods and cyclones. Due to availability of satellite-based meteorological products, aerial and satellite-based digital terrain models have led to development of spatial flood early warning system for various flood-prone river basins of the country. These technologies have immense use in landslide early warning studies also. ISRO regularly prepares for maps using thermal sensors data and provide it to Forest Survey of India and other state forest departments. The near real-time data dissemination through Bhuban and NDM geoportals and estimate alerts help forest department for taking quick action. As NRSC ISRO has the advantage of having historic disaster specific data specific from various satellites, it is used to prepare state district level flood hazard atlases depicting frequency of floods. These flood hazard atlases are used by the state government in augmenting the sustainable growth plan of the states. The geohazard studies are primarily focused on landslides, earthquakes, and volcanoes. High-resolution satellite data are used for post-disaster management and landslide inventory preparation in case of landslide or earthquake. Landslide hazard zonation prepared along major tourist and pilgrimage routes in the states of Himachal Pradesh and Uttarakhand. National NRSC is a lead agency to implement National Disaster Database for Emergency Management (NDM). It essentially serves as a multi-scale geospatial repository at national level, coupled with a set of decision support system tools to assist the disaster managers in decision making during emergency situations. Communication is one of the key infrastructures of any country, and it becomes all the more important during the times of disasters. Space-enabled communication of the nation, particularly useful in inaccessible regions. During disasters, where local communication is snapped and damaged, the satellite communication plays a very crucial and timely role. The role of teleeducation have been highlighted during COVID time, as satellite-based communication has been the weapon of choice for government machinery to tackle the situation and bring services to the doorsteps of general masses. You may not be aware, but space technology shapes all of us in more than influencing our outreach and safeguarding us from various disasters at any given time. It is not just a national interest that ISRO caters to. As a global partner, ISRO is also actively involved with various other countries with regard to disaster management through international frameworks such as International Charter, Space and Major Disasters, Sentinel Asia, UNESCAP, and so on. NRSC ISRO is fully committed to the idea of build back better propounded framework. With the forthcoming launches and host of technological development built, the scientific community at NRSC ISRO is eager, excited, and full of exuberance to serve the nation for disaster risk reduction. I wish that this joint training program of NIDM, MHA, and NRSC ISRO will be a very beneficial in understanding the applications of space technology in disaster management and in disaster risk reduction. Wish all the best to the organizers as well as the participants. Thank you.
Thank you very much, sir. Now I would request Professor Cess von Western, Department of Earth System Analysis, Geoinformation Science and Earth Observation, University of Twente, Netherlands, to say a few words, and we will have his detailed presentation later in the technical session. Over to you, sir.
Okay, thank you very much. Thank you, Professor Surya Prakash, and to colleagues at NIDM for inviting me for this event. My colleagues also from NRSC, among which I know also several people that worked with before, including Tapas Marta. I'm happy to see him also in the group. It's very good that you have this this workshop. It matches exactly with some of the activities that we were also involved with recently, with the in the more regional context in terms of the Asian and Pacific Training Center for Information and Communication Technology, APC ICT, from UNESCAP, and hope we will be able to present the guideline that they developed in a short while about the use of geoinformation for disaster management. So I wish you a very successful training. Thank you very much.
Thank you very much, sir, to be with us. And with that, we have come to end of our inaugural session. Now, moving on the technical session, we have senior level resource person, experts, professional and functionaries who have very long and meaningful experience with vast knowledge on the subject. During the technical session, there will be presentation, and once all the presentations are over, we will take a question answer. And your active participation is very important to us. Kindly use Q&A window only to raise question. Now for our first presentation, we have with us Dr. Manjul Hajarika, Director, Asian and Pacific Training Center for Information and Communication Technology for Development, Thailand, about the ICT for disaster risk management. So I request Professor Manjul Hajarika for his presentation. Over to you, sir.
Thank you, Harjit. I will like to thank all of NIDM and for inviting me for this particular training program. And actually, with ITC Netherlands, with Professor Case, we have developed a training model recently with the help for APCICT, which is based in Korea, and it's a UN center, UNESCAP center based in Korea. Can you see my file?
Yes, sir.
Is visible, right? My PowerPoint is visible, right?
Yes, sir, it is visible.
Okay. So this one, we have the one module, actually ICT for disaster risk management, we have developed jointly. And this is actually, they are going to roll out this training module in different countries of the Asia and Pacific region. So today we thought that maybe it's a good idea to introduce this module to the audience, and there are two parts. First part, I'll talk about the overview, whereas Professor Case will explain detailed contents. And myself and Professor Case, we have been working for almost, I think, 15 years. And also, maybe we also developing a open source multi-hazard risk assessment tool, which have Professor Case and our center, which we expected to be ready by beginning of next year, which will be open source primarily, and it will be cloud-based system. I think with that kind of module available, our hands will be strengthened over the time, I hope. So let me go to the presentation. So here about AIT, Essence of Technology, is an international postgraduate institution, and we have last year actually we got a kind of recognition in SDG Goal 1, 19th ranking in the world, 30 academics program, and we have 23,000 alumni from more than 100 countries. ITC also they develop capacity, particularly in less developed countries, to utilize geospatial solution to deal with national and global problems. And there are a lot of alumni even in India. I think some of them present here today. And they have a large alumni network, MSc, PhD programs, online program, and they basically focus on development-related activities. So with that introduction, I will go to this about the module. The motivation for this developing this module is this: according to IPCC, as you know, disaster hydrometeorological hazards are on rise because of probably climate change is one of the factor, and the number of disasters globally increasing. Also, we know that population increase and urbanizations, also a lot of development in high risk areas. So that's also another cause of increasing this disaster. Data shows that economic damage is also on rise due to rapid economic growth. In fact, this is much more than human casualties. In fact, human casualties comparatively in some countries is decreasing actually, but economic damage is exponentially increasing. Disaster risk management is a key factor for achieving sustainable socio-economic development. There's no denying fact on that. Advances in information communication technology, ICTs, offer tremendous potential for DRM, which is ability to collect, analyze, and share data and information instantly, including now this is becoming with this big data, 5G technologies. I think this is becoming much more important and relevant to many sectors, including disaster. So the objective of this module is to introduce the basic concept of disaster risk management and its application of ICTs in disaster mitigation, prevention, preparedness, and response and recovery. So there are a lot of material already available on use of ICT disaster, but these are very general. Sorry, I need a meeting. I'll call you. So this is a very most of these materials are in general type of. There is no specific for disaster management cycle, as I said, mitigation, prevention, preparedness, response, and recovery. So this particular material is very.
Sorry to interfere, sir.
Cycle.
Sorry to interfere, sir. Sir, kindly can you make your presentation in slide share, like slide view, sir?
Okay. Okay, I can do that, but it's so I don't know. Yeah. Is it better now? Hello?
Yes, sir.
Yeah, okay. So target audience of this module is policymaker and civil servants at national and local levels who are responsible for DRM activities. I think this will be very relevant to India, and I know NIDM also doing a lot of, NRSC also doing this kind of training program for policymakers and civil servants. Okay, so to do this, to develop this module, expert group meeting from 26 to 27 August 2019 in Bangkok. Nearly 30 experts from academia, government, and participate. The main objective of this AGM was to solicit comments and feedback from on the draft version of the module to ensure quality and relevance target. So these are all participants there, and there is one many of you know, Dr. Sampati Ray. He was in NIDM a long time back, I think 10, 15 years back. Now he's in IIRS, and also this is the Mr. Ko right side. He is the director of APCICT based in Korea. So, module overview. First chapter is Introduction to Disaster Risk Management. So, students will be familiar with this DRM terminologies, including linkage between Sendai framework for DRR as well as sustainable goals. Chapter 2, we have been focusing on these what kind of data necessary for risk assessment, as you know, which is very important. And the participant will be able to identify the data necessary for DRM, such as remote sensing data, digital elevation model, thematic data, and historical disaster data. So then chapter 3, it is ICT for risk assessment and risk visualization. And these participants will probably appreciate the ways which ICT can be used for disaster visualization and know the basic steps of conducting risks. So the right hand side is this is one project we did in Vietnam. You can see floods in the background, and these are the buildings. How much will be reconstruction cost after a flood? Red one will be high cost, whereas the green one will be a lower side of the cost. Chapter 4 will be mitigation and prevention. Participants will understand how risk information can be used for selecting appropriate disaster risk mitigation prevention measures at various levels, regional, national, and local, and for making decision by considering likely future scenarios. So this is this particular slide, left side, it was actually work Professor Chris Van West, America. So if you take, say, some first one, alternative 1 and 2, which is some physical measures in the ground, then you will reduce by 11% risk by 2050. Whereas the down one, they have some more measures taken, then it will be reduced by 31%. So this is in terms of climate changes, different scenarios taken into account. So he'll maybe explain more. Okay. So the module for chapter 5 is the ICT for disaster preparedness. It will appreciate, participants will appreciate the ways in which ICT can be used for community-based preparedness planning, alerting, evacuating, shelter planning, establishment an early warning system, and impact-based forecasting. So the figure, this is actually, we did a project with ADB funding in Armenia, Bangladesh, Philippines, and Fiji, how we use ICT for community-based disaster management, including also bringing some remote sensing data, particularly Central Malaysia or international disaster chart, which NRS is very familiar with, to make this community-based disaster management. And this chapter 6 is disaster response and relief. So participant will be of the freely available satellite-based resources, products for emergency mapping, mobile application, reporting disaster incidents, robots for search and rescue operation. And the left side one, it is Palu earthquake. Palu, Sulawesi in 2018 is a, I think, 7.3 magnitude earthquake. You can see this liquefaction happen, and all buildings were, houses were kind of in a muddy situation. And it's, so this kind of information also used in this module. So the chapter 7, disaster recovery from using ICT, to know the ways which ICT can be used to support disaster recovery, including post-disaster building damage assessment or post-recovery monitoring. And you can see this figure right side. This is a 2005 this earthquake in Chengdu, and then how this has been underway in that place. First one is the pre-earthquake 2005, and 2008 is the that earthquake happened in 2008, and 2011, 2017. So you can see this kind of recovery using ICT. The chapter 8 is actually, this is not exactly, I mean, directly closely tied with the other chapters, but as we know that gender issue is important. If you look at 2004, this big tsunami or other big events, particularly some of the countries like Indonesia, their number of women killed is 2 times or more. And some of the cases in Bangladesh, we have also seen that more women kill more because they are more vulnerable from the various regions. This we try to include, address this issue also in this module. So then also some of the, as I said in the beginning, this is for policymakers and management people in the ground. So we have also, for each chapter, we did some policy recommendation. I will not go through all details, but this module is freely available, downloadable, so you can look at later. And it is as the chapter-wise. First, the risk assessment visualization, which is, for example, communicating with the communities at risk. You have to communicate about risk assessment. And ICT can play a great role using mobile application. They can access the information, and also in remote areas. So this is something how we can achieve that some policy recommendation. Similarly, mitigation and prevention, preparedness, response, recovery was the final chapter on gender. So I think from my side, I know how to my
Thank you. Maybe if the moderator can allow me to share my screen.
Yes, sir. Now you are the presenter, sir.
Thank you. Okay, I'm now sharing the screen. Is that correct?
Yes, sir. It is visible.
Yes. I would like to follow up on the presentation by my colleague Mansour and talk a bit more about the content of the academic module on ICT for disaster risk management that has been developed. As Mansour said, it's a training guide. It's been developed for the Asian and Pacific Training Center for Information and Communication Technology for Development, quite a word, APC ICT, which is part of the UNESCOP. You can download the training guide from the link provided here and also have a look at the webinar that introduced the training guide. So as Mansour said, the training guide is composed of 8 chapters. In the first chapter, we set the framework of ICT for DRR by giving, say, introductions on, say, what disaster is, what disaster management is, how does ICT play a major role. For example, here in the disaster management cycle, indicating with colors what are the major phases where ICT and specifically also geoinformation plays a major role. We also highlight the importance of, say, the workflow within in the use of spatial data and ICT information for taking decisions in disasters risk reduction. Here showing, for example, workflow between stakeholders and what they would do if they would analyze existing risk, but using this as a form of an information tool for decision making. By selecting optimal risk reduction measures, they would have to go through the same procedure, but then analyze how risk would change if they would have an alternative like protection against flooding or evacuation, an early warning. Also, the analysis of how the situation would change in future, so different future scenarios, having information on what would be changes in hazards, but also expected changes in land use and population in future, and how would that affect the risk, so that we could take the best risk reduction measures that would also be optimal in the future. For that, we need a lot of information, and so chapter 2, which is a big chapter, deals with what are the different sources of geospatial information available. Nowadays, a lot of information is available online, is also freely available, especially related to remote sensing data. You are very fortunate in India to have NRSC, have ISRO with all its capabilities. We have in Europe, for example, we have ESA, we have the Copernicus program, and so we have also free satellite data nowadays with the Sentinel program, allowing us to get high temporal information that could be used for monitoring. Digital elevation data is a major issue also for a lot of the applications, and other types of thematic data where more and more data becomes available, historical hazard data, and say already analyzed hazard and risk information. So one of the developments, we'd say, in recent times is cloud computing, where on platforms like Google Earth Engine or other platforms, you can make dedicated services for monitoring hazardous events, for mapping them, for example, using Sentinel data, mapping landslides in an automated way, or land use changes, or flooding. A lot of this is now going on, and many of these services now also become available. An example of this that we recently did, also with support from NRSC, was to look at the landslides in Kerala that were generated in the 2018 monsoon event. We also collaborated with GSI. They also provided their landslide points, and we also did an analysis of how much of these landslides were actually caused by land use change. Other type of thematic data is population information. That's very relevant. And so in the guide, we also look at different sources of population data available worldwide and say there are different methods for generation and their quality. Taking, for example, the recent GHS, Global Human Settlement Layer, developed by ESA JRC, which also is for a number of different years, and Facebook population density maps that are providing information at 30 meters resolution. So on that level, a lot of information is available. One of the key aspects, I'd say, in disaster risk assessment is to have appropriate information about the built-up areas. And for that, OpenStreetMap is supported very much as a tool for collaborative mapping, where also at community level, organizations could collaborate in generating up-to-date information on buildings, roads, and other infrastructure. Also here, satellite remote sensing is very important, but it has to have a component also of collaborative mapping to characterize the buildings on the ground, and also the population distribution. Another very important aspect highlighted within the guide is the importance of having historical disaster data, say development of disaster databases, where at the local level information is stored also geographically, so with the geographic coordinates, with the date, so that it could be used also for better estimation of hazard and eventually also risk assessments. There's also a lot of already available hazard and risk data available at the global level. I think one of the major efforts there was the Global Assessment Report for Disaster Risk Reduction, which also produced a global risk atlas, and in there a few years ago also had a global data portal where probabilistic risk results are displayed, can also be downloaded, can be used at the local level, although say they have to be improved at the local level because they were generated for fairly large areas. The third chapter of the guide deals with the actual risk assessment. So what different methods could be applied for risk assessment, and in which situation would we apply which method, also depending on the aims of the stakeholders and also the availability of the data and the scale of analysis. So we look at the different risk components, also for the tools and how we visualize risk for stakeholders. Here we also present a number of examples of tools for risk analysis that are available internationally, such as OpenQuake or HASAS, or a more simple one called INASAFE that analyzes exposure. One example of, say, such hazard and risk data portals at a more, in this case, a national level, is an example of the data portal that we developed ourselves some time ago, in Tajikistan, which is a data portal where you can analyze the risk at district level or at municipal level. And so it had components where you can visualize hazard information. It's a multi-hazard, so it has 8 different hazards with elements at risk information, so population, buildings, roads, agriculture. You could analyze the exposure, so per administrative unit, see how many, as for example, buildings are exposed to earthquakes, population exposed to flooding. Then follow up is the loss map, so calculating how much loss there would be, which also incorporates their vulnerability. And we calculate the risk, and then we can run a risk profile for a municipality, which means you select the types of hazards you're interested in, the administrative unit, and then the system will generate a complete risk profile, which could be printed out as PDF and can be used by the decision makers. Such type of platforms are becoming much more popular now. The fourth chapter, dealing with mitigation and prevention. This is where we are demonstrating how risk information can be used to take decisions to reduce the risk. So to formulate risk reduction alternatives, structural measures, non-structural measures, how these would influence the risk, and also how you could analyze which ones would be most beneficial in terms of a cost-benefit analysis or cost-effective analysis or multi-criteria evaluation. A very simple example of that, example of a floodplain illustrating what could be the risk of buildings at the current level, now only in a very simple example looking only at one, say, flood level, but then illustrating how risk changes when we are, for example, installing embankments, or when we would improve the vulnerability of existing buildings, or when we would do relocation planning, and then seeing, okay, on the basis of number of people exposed, but also the risk reduction in monetary values, how you could compare those. Another example we show is modeling of that. You show how risk might change over time. And of course, there's a lot of effort being done now to do these kind of scenario calculations over large areas. But for decision making, it's also important to have it at the catchment level, or say at the city level, seeing what are the current levels of risk, how would they change in future under different, say, climate change scenarios, but also land use change and population change scenarios. Then, analyze the future trends in that, and so also look at what kind of possible planning alternatives there are for risk reduction, and see how these combine under a climate scenario. So which of the risk reduction alternatives are best change proof over time. One of the tools, and I think mentioned already by Mansoor, is development of spatial decision support systems to aid decision makers in taking decisions on which options could be useful, the best for risk reduction. So this is a system that's currently under development that has technical modules and decision support modules, where in the technical modules you go to loss estimation, risk analysis. You formulate in the decision support modules alternatives and scenarios, and they would go back to the technical modules where you calculate what their implications are in terms of changing elements at risk, vulnerability, and hazards, and then do a comparison with them, also using a cost-benefit analysis as well as multi-criteria evaluation. In Chapter 5, we are looking at preparedness planning and how ICT plays a role in there. And there, of course, aspects like early warning system are extremely important. They are key in this phase, but also at the local level, preparing at community-based preparedness planning and communication. where ICT plays an extremely important role. One of the important developments there that we want to highlight is the not only early warning, but what we would call impact forecasting. So not just a warning that an event might happen with a certain magnitude, but also trying to predict beforehand what the impact of that event might be, in terms so that decision makers can allocate funding and resources already before the event has taken place in order to alleviate the damage and the losses. This is typically an example in areas affected by tropical storms, cyclones, where days before the cyclone would arrive, you run models predicting where the impact might be highest and anticipating on that. That could also be, for example, in relation to monsoon events. In chapter 6, we focus there on disaster response. And so we illustrate how, give examples how ICT can be used for disaster response. They're highlighting a lot on damage assessments and say both using satellite data, but nowadays also at the local level. A lot of new technology is being used in the search and rescue operations, also using UAV drones, using robotics and things like that allow rescuers to access people that are trapped within buildings. Also, the application of mobile phones in disaster events, and also one section deals with the ICT to respond to COVID-19 as illustration. One example of such aspects there is the GDAX, Global Disaster Alert and Coordination System, which has been developed by different organizations, including European Union, Joint Research Center, but which provides a lot of information just prior to the event, not just say the warnings, but also a prediction of the intensities and the likely impacts of those. And also initiatives such as International Charter for Space and Major Disasters, UNOSAT, and other agencies that are very much involved in providing support after a disaster event. This is a brief highlight of this training guide ICT for disaster risk management. As I said before, it's available for download. Later on, it will also be offered by APC ICT as a course, most probably initially also as an online course. Quite similar actually to the setup that NIDM has been initiating in this case. But then later on also a plan was to do this, face-to-face training within different countries. So thank you very much for your attention.
Thank you very much, sir. Professor Manzul and Professor Keswan Wesson to share their vast knowledge and experience with our participants. Like they highlighted an overview on information and communication technologies module for disaster risk management. DRM ICT module for DRM play a significant role in disaster prevention, mitigation, response, and recovery. Timely, predictable, and effective information is much needed by the government agency and other humanitarian actors involved in rescue, operation, and decision-making process. Sir, there are few questions raised by participants. How this module can be implemented by the policy makers at the state level?
Mansul, do you like to comment on that? Okay, maybe if Mansul's not there, let me answer that. I think this is not a kind of a step-by-step guide. Let me put it like that. This is more as it is giving an overview of what options are there available for using ICT in different phases of disaster management. And so whether that would be applicable at the state level or at the local level, that is that there are no specific guidelines here on the standard operation procedures or so for such levels of administration, but it gives a lot of examples on how ICT has been used in different levels of administration in Asian countries. So that's the aim of the course. Thank you.
Thank you very much, sir. Sir, one more question. As we know that different geographical area have different disaster risks. So how to understand what are the information needed in successful implementation of ICT DRM?
Yes, thank you. That's a very interesting question, because I think that what we actually need is a hierarchical evaluation going from a national level, or actually international, national, and then going to a more local level, where inventory of existing hazards is first done at the national level, and prioritization of regions with respect to hazard and risk. And then based on those, say, national scale levels, also priorities are set for what needs to be known at the more local levels. And so that also depends on the stakeholders involved. For example, whether there should be a lot of information available for agriculture in the case of hazards that affect crop yields, or whether it would be hazards that would be much more affecting human population and built up infrastructure such as earthquakes. And so the knowledge stream from national to local, and say incorporation of different requirements in terms of the impact hazards on society are very important here. Thank you.
Once again, thank you very much, sir, to join us and sharing your vast knowledge with our participants. Now move to our second presentations. We have with us Dr. KHV Durga Rao, Group Head DMSHG, RSA, NRSC, who will enlighten us on role of NRSC in monitoring and management of flood and cyclone. Over to you, sir.
Respected Director NRSC, Professor Van Westen, Dr. Manjul Hajarika, and Professor Surya Prakash, and all other training participants, those who have joined. Good afternoon to everyone. I welcome you all for the 3-day training program jointly organized by NIDM and National Remote Sensing Center. Madam, can you hear me?
You are audible.
Yes, sir. Audible, sir.
The presentation is visible?
Not yet, sir. I think, sir, you have to share the presentation once again, sir.
I have shared already.
No, sir, the presentation is not visible, sir. I think, sir, kindly stop sharing, sir. You can once again, sir, try to share the presentation. I think there is.
It is not visible.
No, sir. Sir, I will request you to first, sir, kindly stop sharing, then share it again, sir. Yes, sir. Now it is visible.
Thank you very much. As you all aware that India is one of the worst flood and cyclone affected countries in the world. As space technology, it is a unique technology which gives very vital information during all three phases of the disasters for effective disaster risk reduction in the country. Today, I would like to showcase our operational activities being carried out at National Remote Sensing Center. So how towards achieving the goals of Sendai frameworks using Earth observation data in disaster risk to the Indian subcontinent. Keeping in view of the advantage of space technology, ISRO has established a decision support center at National Remote Sensing Center under Disaster Management Support Program as a single delivery point for space and aerial based inputs to support disaster management in the country. The major activities of this ISRO DMS program at NRSC are near real-time monitoring and mapping of all disasters like forest fires, landslides, earthquakes, etc., and generation of flood vulnerability and hazard zonation maps to support disaster risk reduction. Specific multi-scale disaster database through National Database for Emergency Management. It generates high-resolution digital terrain models using aerial platforms like LiDAR DTMs. And we are working on R&D in, we are doing R&D in spatial flood early warning and other disasters also. So my colleagues will discuss subsequently on that. I'm concentrating on floods and cyclones particularly. And we do capacity building to stakeholders in all the disasters. How we support disasters using space-based inputs. Inputs to Ministry of Home Affairs and National NDMA, CWC, State Disaster Management Authorities, and other stakeholders. And we do support international different countries by providing our Indian remote sensing data. And we also receive remote sensing data from various space missions through International Charter and Central Asia frameworks. For near real-time monitoring and mapping of flood cyclones or for disaster management in other phases of the disasters, we need a very strong network of space and ground assets. For coming to the India, we have different satellite systems like communication satellites for effective communication during in the event of disasters. To reach the communication to the very remote places, we have a number of communication satellites in geostationary orbits, and we have Earth observation satellites for imaging the Earth at different temporal resolutions, different spatial resolutions. We have some satellites in geostationary orbit. We have satellites in sun-synchronous orbits like ResourceSat, Cartosat, etc. We use a lot of Indian remote sensing satellite data during the disasters. To monitor these floods and cyclones continuously on day-to-day basis, we take support from other satellite data sets also like RadarSat data, Sentinel-1 and 2, MODIS, LATE. Forms and to get the data from various space missions like LS2, TerraSAR-X, SACOM, Pleiades, Worldview, Canopus, RCM, etc. And we have aerial platforms. These platforms are used for major disasters, for example, tsunami and other major cyclones when Hudud struck India. So during such type of big disasters, we fly and we acquire very high resolution data, and we analyze and provide the information. And we have in-situ observations, like a lot of AWS stations are established across the country. Our MOSDAC, one of the centers, SAC Ahmedabad, they monitor the metallurgical data and everything. They provide information. The data, ground and space assets we have for monitoring and mapping of floods and cyclones in all the three phases. And coming to the different type of satellite data sets, we use microwave data very extensively, because it is a cloud free. It can penetrate to the clouds. During floods and cyclones, we'll have a lot of clouds, so that the microwave data is very useful for near real-time monitoring. And we use very high resolution data for damage assessment also. So at different resolutions, we use data sets which covers different swaths across the country. Now, coming to the response phase, what we do. So before starting of a monsoon period, we prepare pre-disaster database, means what are the river systems, what are the river courses, etc. And coming when during the disaster period, okay, we have very strong disaster watch mechanism. So we go through the news media, and we go through the satellite-based rainfall meteorological products, and we go through other websites like Central Water Commission, India Meteorological Department websites. Once we foresee any disaster, immediately we acquire satellite data. First, we will look into our Indian remote. In absence of IRS data, we go for other data sets like Sentinel, radar set, etc. As I mentioned, if the disaster magnitude is big, and we activate international charter also to get data from other satellites. After receiving the data, we analyze very thoroughly by applying different digital image processing techniques. These techniques are different for optical and microwave sensors, and we prepare a flood map from that. Then once the flood map is prepared, and we thoroughly check with the field authorities, and after that we integrate, we subtract the pre-flood data from the flood map, so that we get the exact flood inundation layer. Then we integrate with large-scale geospatial database with that, like roads, point of interest data, settlements, village layers, etc. So which will be a meaningful information. Then we prepare different flood maps in real time. Apart from that, we prepare so many value-added products like flood persistent maps and flood duration maps and damage to the agriculture, etc. And once we prepare this, and we disseminate through a mail system, directly we disseminate to the concerned state disaster management authorities through emails immediately, and we disseminate through NIDM Geo web portal, we disseminate through Bhuvan Geo web portal also. So all this activity, starting from disaster watch to dissemination, our turnaround time is 3 to 6 hours maximum. So because the turnaround time is very important in disaster restriction during the event of any disasters. So coming to near real-time monitoring and mapping of floods. So we do monitor all the floods, all medium to major floods in the country with the turnaround time, maximum turnaround time of 6 hours. In 2020 itself, India witnessed floods in 14 states almost. So we mapped all flood events without leaving any single event, and we disseminated about 245 flood maps to the state disaster management authorities. This year itself, we activated international charter 4 times during major disasters like Amphan cyclone, which is a very major cyclone struck India during May month, and Assam and Bihar witnessed prolonged floods this year. And there were major landslides and flooding also in Kerala. During all these 4 events, we activated International Charter, and we received data from almost 14 satellites across the globe. We disseminated all the products near real time to all user organizations. Generally, these maps, maps are being used by state authorities in relief and rescue operations and damage assessment and disaster management activities. Here you can see here the floods in Assam and in this year particularly, and sometimes we prepare because satellite image, will acquire some part of the image only based on its swath. So we prepare cumulative flood maps also, so that you can visualize during 16 July to 7th August, what was the flood affected area in Bihar. You can see Kerala floods, major floods in 2018. Recently we received, Andhra Pradesh also witnessed floods in Godavari river, and these are images of the floods. And coming to the cyclones, cyclone monitoring and mapping, it is something different. Because during cyclones, the flooding will be less, and the damage due to wind is more. Damage due to wind on urban infrastructure is very high. Okay, even though we monitor the floods if there is any flood at all during cyclone period, and we do damage to the urban infrastructure and rural infrastructure using very high resolution satellite data. You can see here during Fani cyclone, the damage to urban infrastructure in Bengal during this year in Amphan. So in recent years, we monitored Amphan, Nisarga, Fani, Titli, Gaza, Petai, Oki, all cyclones. We don't leave any cyclone. Okay, if there is any damage or any flooding, immediately we map it and disseminate to the users. Apart from the maps, as I mentioned, we prepared so many value-added products. For example, flood progression and decision maps. Here you can see one small animation of one part of Assam. So this will give you an idea how flood is increasing, how flood is receding in that particular area. And we prepare flood cumulative flood duration maps. These flood duration maps are very much useful in damage assessment, particularly. A particular agriculture crop, if it is under flooding for 1 day, the damage is different. If the same agriculture crop is under flooding for 1 week, the damage is different. So this type of duration maps are very much useful for damage assessment. And this year we started an activity to give crop area affected during the flooding, in seasonal crop area affected. So crop map prepared using micro data and overlaid with the flood maps, so that you can get what type of crops are inundated and what duration, so that it is very vital information in the insurance sector. So this type of value-added products also we disseminate in real time to the all stakeholders. If you look at during last 4 years, in 2017, India witnessed floods in 8 states and 108 districts, of almost 101 products we disseminated. And the floods are increasing year by year. If you see the graph here, in 2009, India, one of the worst flood affected year in the history of India during last 10 years. Almost 14 states witnessed floods, and we prepared almost 254 maps and disseminated almost daily one map covering all the flood events in the country. And this year also is one of the worst flood affected in the history of India. This year also almost 14 states affected by the floods. We prepared almost 245 maps using multi-mission satellite data, and we disseminate to the users. So our aim is we should not leave any event, any moderate to major floods in the country, anywhere in the country. And this is the response phase, what I have shown just now. Coming to the mitigation phase, how space-based data is useful in mitigation phase I would like to discuss here. Having the advantage of historic satellite data, long period historic satellite data, we prepared flood hazard atlases for major flood-prone states in the country, like Assam, Bihar, Odisha, Andhra Pradesh, West Bengal, Uttar Pradesh, etc. So, what are the advantages of this flood hazard atlases? This is one of the best non-sectoral method for flood disaster risk reduction. It is very useful for controlling developmental activities. So, and useful in planning relief and rescue operations, and useful in planning and relief rescue health centers also. So, prior to the disasters, so the state disaster management authorities can plan where to construct relief and rescue centers and health centers based on the other atlases. It is very useful input in growing flood tolerant crops. For example, states like Assam, Bihar, Odisha, where the floods are very frequent, so they have to go for the flood tolerant crops. So they can plan flood tolerant crops in those areas. It is vital information for flood insurance sector. This is one of the sector growing nowadays. And important parameter in reservoir operations also. Once you know that which is highest flood prone area, which is lowest flood prone area, the concerned organization, they can regulate the reservoirs accordingly so that the flood can be minimized in the downstream side. So this information is very useful during pre and post disaster events. So how we prepare this flood hazard atlas in brief, I would like to explain here. You can see here in 2020, this is the total flood affected area in Odisha state. Okay, but here interesting thing is Mahanadi received floods in the month of August, and some parts of Odisha received floods due to Amphan cyclone in the month of May, and some parts of Brahmani Baitani received floods in the month of July and August also. So if you prepare a cumulative flood map, so this will give a synoptic view of the flooding, complete flooding in the state. So we prepare annual flood maps that will give the picture that what is the total flooding in that particular year. So all annual flood layers will integrate. I'm giving the example of Odisha flood hazard atlas. So annual flood layers of 1998 to 2018 are prepared and integrated. And we obtained water level data from Central Water Commission, and we integrate it. That will take care of the in-seasonal variations. And after integrating in decision support system environment, we prepare flood maps, flood frequency maps, which shows very high to high, moderate, very low zones, flood affected areas. And this further integrated with large scale geospatial database, having village level information, roads, point of interest, etc. So it will give a very meaningful map and for disaster risk reduction in the country. So here I'm showing here the flood hazard atlas of Odisha. It was released in the last year itself by Honorable Chief Minister of Odisha. This atlas was prepared using 100 satellite datasets of different period. Recently, we prepared a updated flood hazard atlas of Bihar state using 275 satellite datasets of 1998 to 2019. So that atlas, we are waiting for its release. Maybe shortly it will be released. And atlas of other states are in preparation, as I mentioned earlier. Sorry. Here I am showing you district level flood hazard maps. Once we prepare state level maps, then we can extract district level, because the database is at village level particularly. So you can see here in this particular districts, what are the very high prone to very low flood affected areas. So these maps are very useful in planning developmental activities. Generally, any city will grow along the river. Okay. So the state authorities can regulate the construction activities along the major floodplains. Coming to the early warning phase, spatial flood early warning for disaster risk reduction. Whatever satellite data, it can give near real time after the. But if I want to know the flooding prior to the event, I have to use the simulation methods using very high resolution digital elevation models and space-based inputs. So this early warning, the advantage of flood early warning is it is the best method, non-sexual method that gives the spatial flood early warning prior to the event, so that if we can know that flooding in any area at least 2 days prior to the event, so you can do the rescue and relief operations, you can save the life and properties so that the damage can be minimized to the great extent. Categories of flood forecasting: we have short range forecasting, we have medium range forecasting, we have long range forecasting. Generally, Central Water Commission, they do short range forecasting using conventional techniques. So coming to the medium range forecasting, it can be done using hydrological modeling techniques. Coming to the long range forecasting, if we want to improve the forecast lead time, so we have to integrate the satellite based meteorological products also, so that the forecast lead time will be more, so that we can give early warning at least 5 days in advance, so that will help us in reducing the disaster risk greatly. So what are the new trends and technologies available in this flood early warning, spatial flood early warning? Use of distributed modeling approaches, availability of satellite-based digital elevation models for hydrological modeling, availability of high-resolution digital terrain models for spatial inundation simulations modeling, availability of advanced modeling softwares, high-density field observations like automatic weather stations, and advantage of geospatial technology. All new trends at one platform, so that we can give a much meaningful information prior to the disasters. Keeping in view of the audience, different spectrum of audience are there, so I don't want to go in depth of, I'm not going to depth of technical discussions. So I will concentrate mostly on the role of space technology part. Okay. Coming to the satellite-based digital elevation models in hydrological modeling and spatial flood early warning, we know that we have coarser resolution digital elevation model to very fine resolution digital elevation models or digital terrain models. These are useful in hydrological modeling and hydrodynamic modeling, and finally spatial. What is the advantage of this spatial flood early warning using space-based inputs? Coming to the simple comparison between conventional technique and a modeling technique. Modeling technique is based on space-based inputs. The forecast, conventional technique is a short-range forecast. That means you will get forecast maximum 40 hours. Generally, it is 12 to 20 hours, 12 to 24 hours. But in such cases, the relief and rescue operations and mobilizing the disaster rescue teams is very difficult. Coming to the modeling techniques, it is medium to long range, so that you will have sufficient lead time to mobilize the rescue teams for relief and rescue operations. As I mentioned, it is a gauge-to-gauge correlation technique. It is a modeling techniques, and accuracy also very good in modeling techniques if you thoroughly calibrate and validate the models. And the data requirements, of course, in conventional techniques, minimum data required, we need only the observed gauge data only. In modeling techniques, we need more data on topography and hydrometeorology. And in disaster risk reduction, the modeling technique is very effective. And the data requirements, we need some static data, we need some dynamic data. Static data like completely based on the space inputs like land use, land cover, digital terrain models, soils, etc. Dynamic data we take real-time discharge data from upstream reservoirs and daily rainfall data. Nowadays, satellite-based rainfall products also available, so that we can use in near real time for hydrological modeling and flood forecasting. This is the work. This is a broad methodology of flood forecasting, as I explained in the previous slides. So we have topographic data derived from digital elevation models, either satellite digital elevation model or aerial-based lidar digital elevation models, and we have other space inputs like land use and soils. We have meteorological information like historic data, real-time data, and forecast data, mainly from space-based input data here, and we develop models, and we calibrate the models, and we validate the models. Once the flood forecast model is calibrated, validated thoroughly, and we spatial inundation simulation models and integrate it. It is a coupled model, like a hydrological model and hydrodynamic model. So hydrological model will give you the flood hydrograph, and hydrodynamic model will give you the flood routing and subsequent spatial inundation simulations. So finally, we can give the spatial flood alarming. Once spatial flood inundation simulation model is ready, it will give you at least in 2 days in advance what villages are going to be affected by the floods. If I integrate with the other geospatial data, I will know everything, what villages is going to be affected by the flood at what time. And another advantage of this spatial flood modeling is, in remote sensing, you will get only the extent of the flooding. But in spatial flood early warning, you will get the depth of the flooding, which is very vital information in damage assessment. If a crop is inundated, if the depth of flooding is 1 feet, the damage will be different. If the depth of flooding is 10 feet, the damage will be different. So the depth information you will not get using remote sensing data, but in modeling techniques, you will get the depth of flooding, you will get the velocity of flooding also. These are the very vital information in disaster risk mapping. We developed a web-enabled flood forecast systems for 3 major rivers: Godavari, Topi, and Mahanadi. And we developed flood early warning models for other 10 rivers. But these 3 rivers we operationalized with the support from Central Water Commission and from India Meteorological Department. So these models are developed and very well calibrated and validated. You can see here these models, Godavari flood forecast model calibrated and you can see observed and computed hydrographs for different years, historic, using historic data. After a thorough calibration and validation, and we started using operationally in real time, using the real time rainfall data, point rainfall data received from IMD, and forecast rainfall data, satellite-based forecast rainfall data received from IMD, WRF data. Similarly, this is the Topi model I'm showing here as another example. You can see here the calibration validation. This peak flood discharge estimation is more than 80% accurate, and the inundation simulations are more than 90% accurate. So compared to the field observations, this is the Topi forecast model. And as I mentioned, the modeling is 1D and 2D modeling. We have to couple it. Both the Topi and Godavari I'm showing here. These modeling, spatial modelings are models are developed using lidar data acquired by NRSC itself. You can see here the cross sections of the river profiles at different locations, and we have to couple the hydrological modeling and hydrodynamic modeling so that you will get the flood inundation simulations. This is the Godavari flood inundation spatial flood forecasting. You can see here. If you go to our own website or and our NHP portal, National Hydrology portal, you can see this the spatial flood early warning for Godavari and Topi rivers. You can see here the flood hydrograph at a particular station. You can see here the spatial flood, how it is. You can see the animation also here, how flood is increasing and receding. In the background, you can see one satellite image, radar sat image is there. you can see how accurately our inundation simulations are matching with the background pattern you can see, and the front blue cyan color is the simulations. And the advantage is here is at any interval, 1 hour or 3 hour, whatever interval you like, you can simulate it so that you can know how flood is increasing and how flood is receding, and you will know what is the depth of flooding also. You can see here depth of flooding and velocity of flooding also, and the flood discharge accuracy is more than 85%, and lead time also. Lead time forecast means if flood comes at 12 o'clock in reality, our forecast lead time will be plus or minus 2 hours, maybe 10 o'clock or 2 o'clock. It is very accurate. And improved lead time. So we are giving forecast 50 hours in advance to the event, 50 hours prior to the event, so that this will help in relief and rescue operations and flood damage risk reduction. Once you integrate with a large-scale geospatial database at village level, then you can give the flood alarms to the concerned villages, relief commissioners, and disaster management authorities and the ground. You can see here the Godavari. After integrating with village level information, you will know what village is affected by the flood, what is the depth of flooding. Very clearly, you can see here. So this information can be possible using very high resolution digital elevation models through modeling techniques only. Here I'm showing the Topi. You can simulate through Bhuvan or Google Earth also how the flooding is propagating from this is the Ukai Dam in Topi River, how flood is propagating through the river to the downstream delta area, and what is the depth of flooding also in real time you can see. So that this will give very useful information in disaster risk reduction. This information tied to the event itself. Apart from contribution during all 3 phases of disasters, like in response phase, mitigation phase, and early warning phase, we do support our IRS data to various countries through International Charter and Central Asia forms. Here I'm showing here during last 3 years, about 133 IRS datasets were provided to 18 countries through Central Asia to address 56 disaster events. This year, you can see here the Lebanon bomb blast. We provided a Cartosat very high resolution image. You can see very clearly what buildings are damaged. We can see very clearly. In 2019, what data we provided in 2018, what data. I'm showing here the during last 3 years only. So we provide a lot of data to various other countries during the disaster events for all disasters type like floods, earthquakes, landslides, and volcanoes, etc. And through International Charter also, we provided a lot of data sets during recent years, 2017, 18, 19. You can see here Indian remote sensing satellites for different events, how we provided through our International Charter. As we receive data from other sources, other countries, we also provide data to other countries. This is the international bilateral agreement. And we do the capacity building also. So to understand how to make use of space data, remote sensing data on the ground. We provide every training program, 1 week training program to the user organizations. And we provide short duration training programs on NIDM, National Database for Emergency Management also. So this year itself, during 2020 itself, almost 120 people we trained in this year. We organized a national conference on flood early warning last year itself. It was a mega event. Almost 175 delegates participated. Various decision makers, secretaries from various state government organizations, and NDMA members, many top dignitaries working in the disaster management field have attended the conference. And how we disseminate the data, what we prepare, the flood maps Not only flood maps, all disaster-related specific products. We disseminate through NIDM, National Database for Emergency Management. It is a multi-scale geospatial data repository coupled with decision support tools. So, this we disseminate all through this, and we have NIDM mobile also developed, so users can get the data through these two platforms. And for general public, we disseminate data through Bhuvan Geoportal. We can see here Geoportal. I'm showing here the flood map of this particular 2020 itself, Bihar area, the floods in Kosi and other rivers of Ganga system. So these maps also you can see here. You can make use of these data sets. So what are the final end use of these data products? Very helpful in disaster risk reduction. Valuable input in relief and rescue operations, in planning relief and rescue and health center, controlling developmental activities, important input in crop insurance. Finally, it input in build back better in recovery, rehabilitation, and reconstruction of the society. So, if anybody has any specific questions, they can contact me at this email address. Thank you very much.
Thank you, sir. Before starting our question and answer round, I want to say that we have joined by 810 participants and several other watching YouTube live, sir. So let's start our question answer round, sir. Sir, due to time constraint, we will take 3 or 4 questions. First question is raised by Dr. Rakesh Ranjan Thakur. How coastal vulnerability assessment using geospatial technology is useful in management of disaster related issues?
Okay. Actually, we have some another couple of lectures also. Okay, on from Geoscience Division and NM. Okay, so after all the 3 lectures, people will get more idea on all the disasters. Coming to the coastal vulnerability, coastal flooding is different. Okay, particularly. If it is due to cyclonic flooding, I explained how we do cyclone flood mapping and how we do damage assessment in coastal areas. Okay, so coming to the flood modeling, so in coastal flood modeling is a completely 2-dimensional flood modeling, because apart from your river inflows, you will have the backwaters from the sea also. Okay. So we work on that also. We are working on that particular field also, the coastal flood mapping, so that if you integrate with other socioeconomic data with these inputs, space-based inputs and modeling inputs, you can do the vulnerability and risk assessment more accurately.
Thank you very much, sir. Sir, next question is raised by Kajal Burman. She is asking, what is your suggestion for prevention of natural hazard like cyclones for Bay of Bengal?
See, here I like to be very clear on that. Disasters are a natural phenomenon. We cannot stop the disasters. Okay, but the damage caused by the disasters can be minimized by structural methods and non-structural methods. Like structural methods means by constructing of dams, reservoirs, okay, and by embankments, etc. Non-structural methods are like using space data, whatever I have explained in all 3 phases, space data and modeling approaches, flood early warning or flood hazard mapping, flood risk mapping. So by these methods,
Sir, you are not audible.
am I audible?
Yeah, now sir, it's good.
Okay.
Yeah, sir, one more question. It's a very critical question raised by Nishu Bhardwaj. asking that in the major flood map, Jharkhand state does not show any type of flood, while all the surrounding states are flood affected. What are the reason behind that?
Very good question. because um, this year Jharkhand also received minor to moderate floods, very minor floods. Okay. Generally, Jharkhand is mainly hilly terrain. Okay. The flood lead time is very less. The flood recedes within hours. Okay, because of its topography. Okay. Sometimes if satellite data is not available during that particular flood event time, so it is difficult to map. And if the flooding is very small, and generally we don't map also, because when Jharkhand got flooded, there were floods in 5 states at the same time. Okay, major floods. Okay, but we have limited whatever satellite data is available during that period. We have to use the satellite data, those satellite data only, and we have to map it. Maybe due to absence of satellite coverage over that area, we missed that event. That may be the reason. But we know that minor and medium floods are reported in Jharkhand. Very, very minor.
So thank you very much, sir. I think this answer will satisfy our participants' queries. Now, I would request my colleague, Mr. Raju Thapa, YP in Early Warning and Communication Center, GMR Division, NIDM, to propose vote of thanks. Over to you, sir.
Thank you, Dr. Ajit Kaur. So during the, like we have discussed today, during the past 4 decades, like natural disasters have caused major losses to human life and livelihood. The destruction of economic and social infrastructure, as well as the environmental damage. Losses from natural disaster will continue to increase if we do not shift towards proactive solutions rather than reactive. So disaster reduction is both an issue for consideration in sustainable development agenda and a cross-cutting issue relating to social, economic, environmental and humanitarian sector. It is my privilege to have been asked to propose a vote of thanks on this important occasion. I wish to express my sincere gratitude to Sri Santanu Chaudhary, Director NRSC, ISRO, Lieutenant Colonel DC Vasista, Joint Director NIDM, for sparing their precious time from their busy schedule for providing encouragement and support to all our participants. And I also extend a very heartfelt thanks to our honorable distinguished speaker, Dr. Manzoor Hazarika, Asian and Pacific Training Center for Information and Communication Technology for Development, Professor Sas Van Watson, Department of Earth System Analysis and University of Twente, Netherlands, Dr. K.H.V. Rao, Group Head, DMSG, RSA, NLSC, for sharing their vast knowledge and experience. Also, I would like to extend a very special thanks to Executive Director, NIDM, Major General Manoj Kumar Vindal, and Professor Surya Prakash, GMR Division, for providing innovative and encouraging environment, moral guidance, and continuous enthusiasm and valuable suggestion throughout our endeavors. I would also like to thank Dr. K.H.V. Durgarao sir for his constant support in organizing this training program. I also extend my big thanks to our GMRD team, Dr. Harjeet Kaur, who is the coordinator and moderator of today, and Mr. Anil Kathet, and also our IT team, Mr. Balaji, Shobit, and Gaurav, for making this training program a very successful event with their contribution. And a very important announcement for the participant. For tomorrow's program, you can use the same link that you used today to join us in the tomorrow program. And regarding feedback, we will share the feedback link at the end of at the last day of the training program. And you don't have to worry about your attendance, because there is this in Cisco WebEx event, your attendance is automatically recorded. Thank you very much. Over to you, ma'am. Madam, you are not audible.
Okay. Oh, sorry. Thank you, Raju. Now I request host to end the meeting. And once again, thank you, Durga sir, to be with us and coordinate with us. Thank you, sir.
Raju, please end up the meeting. Huh?
Yes, sir. I was actually saving the files. Okay, sir.
Okay, all right.